Hello, I am Srikanth Reddy. In this session, we are going to see the solution of linear algebraic system of equations, particularly non-homogeneous system we will see. So from our childhood onwards, we are solving this type of system of equations where it is not new for us. In our 7th class, 8th class, 10th class levels, we have seen system of simultaneous equations comprising of two variables, three variables like that. As the number of variables are increasing, right? So solving these equations by traditional methods is very difficult. So therefore, compulsory we must rely on advanced methods using matrices concept. So now we'll see how to solve the system of equations non-homogeneous type. So consider the system of m linear equations in n unknowns. So a11 x1 plus a12 x2 plus a1n xn equals to b1, a21 x1, a22 x2, a2n xn equals to b2. Proceeding like this, am1 x1 plus am2 x2 plus amn xn equals to bn. So if you look at this system, which is comprising of total m equations. This is first equation, second equation, m equations, and how many unknowns? N unknowns. If you see x1, x2, and so on, xn, total n unknowns are there. Suppose we want to solve this system. Then the procedure is here. First, we will write this in the matrix notation. Write Ax equals to B, where A stands for the coefficient matrix and X stands for a column vector of unknowns and B stands for the column vector of constants. So to determine whether this system is consistent or not, what we have to do is we have to consider the ranks of the coefficient matrix as well as the augmented matrix. So based on those ranks, we can decide whether this system is consistent or not. So the procedure is, first write the coefficient matrix and augmented matrix. So here the coefficient matrix is A equals to, so what are the coefficients? A11, A12, and so on, A1n. So these are the coefficients. So put that in the matrix style. So A11, A12, and so on, A1n, A21, A22, and so on, A2n, AM1, AM2, and so on, AMN. So this is the coefficient matrix. And augmented matrix, the notation is like this. So what we are doing is we are augmenting the column vector of constants to the coefficient matrix A. So that is known as the augmented matrix. So symbolically we will write like this: A, capital A vertical slash followed by B. So this vertical slash followed by B. So this we will call it as augmented matrix. We are augmenting B with A. What is B? B is the column vector of constants. Now we'll see the procedure how to calculate. So procedure to test the consistency of a system of equations. So what is the first step is, here there are two steps involved here, simple steps. The first step is find the coefficient of the, find the ranks of the coefficient matrix as well as the augmented matrix. The first job we have to do is find the rank of the coefficient matrix and the rank of the augmented matrix. Next, step 2. We calculated the rank of the augmented and rank of the coefficient matrix. Let us suppose that the rank of the coefficient matrix is R and that of the augmented matrix is K. Now, whenever rank of coefficient matrix is not equals to rank of augmented matrix, then we say that the system is inconsistent. Inconsistent means the system doesn't have any solution. Suppose if rank of the coefficient matrix is equals to the rank of the augmented matrix is equals to n, the number of unknowns, then we say that the system is consistent and it will have unique solution. The third type is, If rank of the coefficient matrix is equals to the rank of the augmented matrix, but it is less than the number of unknowns, then the system is consistent, but it will have infinite number of solutions. And it will have infinite number of solutions in terms of how many constants, n minus r arbitrary constants, where n stands for the number of unknowns and r stands for the rank of the coefficient matrix. So these three conditions just you have to check. So to check these conditions, first thing required is you have to find the rank of the coefficient matrix as well as the rank of the augmented matrix. Now we'll see this by using one example problem. So this is the problem. So what he's asking is solve this system x minus y minus 2z equals to minus 2, 3x minus y plus z equals to 6, x minus 3y minus 4z equals to minus 4. So the procedure is like this. So this is the given system of equations. So first here we are writing the augmented matrix. So augmented matrix notation is this one. So what is the augmented matrix? The B vector you must augment with matrix A. So A is here 1 minus 1 minus 2, 3 minus 1 1, 1 minus 3 minus 4, and the column vector of constants is minus 2 6 minus 4 that we are appending to this matrix. Therefore this resultant matrix we are calling it as the augmented matrix. Now this augmented matrix is a combination of the coefficient matrix also. Now we have to calculate the rank of this one. So what we'll do is we will reduce this into echelon form and we will calculate its rank. We know how to reduce this into echelon form. So I have to make this entry, this entry 3 and this one as 0. So for that what I have to do, R2 minus 3 times of R1, R2 minus 3 times of R1 and R3 minus R1, R3 minus R1. So if you do that one, so what you will get is 3 minus 3 is 0, minus 1 plus 3 is 2, and similarly 1 plus 6 is 7, and 6 plus 6 is 12, this one. Similarly 1 minus 1 0, minus 3 minus of minus 1, that means minus 2, minus 4 plus 2 is minus 2, minus 4 plus 2 is minus 2. Now if I make this entry minus 2 as 0, then it is in the echelon form. So for that what I am doing, I am adding row 3 with row 2, that is R3 plus I have to make with R3 plus R2. If I make this one is 0, that is enough. So here R3 plus R2, here a mistake is there. Okay, so minus 2 plus 2 is 0. So minus 2, just if you add this one with this row, that is enough. Minus 2 plus 2 0, minus 2 plus 7 is plus 5, and minus 2 plus 12 is 2. Okay, so if you are doing with the first row also, it is not a problem, but it is recommendable that you must use the second row. Now this is in the echelon form. So once it is in the echelon form, it is very easy to calculate what is its rank. Now I want the rank of the coefficient matrix. My coefficient matrix is up to here. So how many number of non-zero rows are there? 3. And what is the rank of the augmented matrix? That means this complete matrix. Here also the number of non-zero rows is 3. Therefore rank of augmented matrix equals to rank of the coefficient matrix. Therefore definitely this system is consistent and it will have unique solution. First of all, whenever the ranks of coefficient matrix and rank of augmented matrix is same, the system is consistent. If the system is consistent, then you have to check whether it is possessing unique solution or infinitely many solution. To check that one, it is enough if you see the number of variables, unknowns. The unknowns n is here 3. Therefore, rank of augmented matrix is equals to rank of coefficient matrix is equals to number of unknowns. Therefore, this system is consistent and it is having unique solution. So what is that unique solution? That is easy to calculate. Go by back substitution. So 2z, this stands for z, right? So 2z equals to 2. From that z is 1. Next 2x plus 2y plus 7z equals to 12. From that if you plug in z is 1 here, 2y equals to 12 minus 7, 5 by 2. Similarly, next x minus y minus 2z equals to minus 2. From that, you can get x. So this is the procedure. We'll see one more problem here. Solve 2x. So this is comprising of 4 unknowns. Same procedure, write the augmented matrix, reduce this augmented matrix to echelon form by using the row operations. See here it is reduced to echelon form. And what is the rank of the coefficient matrix is here 3, but the rank of the augmented matrix is 4. So clearly these two are not equals. Therefore, the system is inconsistent and it doesn't have any solution at all. Next, coming to this problem, determine the values of A and B for which this system has no solution, unique solution, infinite number of solutions. That means for what values of A and B, this system will have no solution, unique solution, infinite number of solutions. So first, write the augmented matrix for the given system, then reduce this into echelon form. So make this entry and this entry as 0. Next, we made this entry as 0. Now this is in the echelon form. Now we'll see case 1. What is case 1 is if A equals to 8 and B is not equals to 15, then what is the rank of coefficient matrix is 2 and rank of the augmented matrix is 3. So both are not equal. So in this case, the system has no solution. That means it is inconsistent. So that is the case where the system is inconsistent. If A is 8 and B is not equals to 15. Next, second case. A is not equals to 8 and B is any value. You put it any value B here, but A is not equals to 8. Therefore, rank of coefficient matrix and rank of augmented matrix both are same. Rank of coefficient matrix and rank of augmented matrix both are same, and it is also equals to the number of unknowns. So in this case, the system is having a solution that is also unique solution. How will get that unique solution? By back substitution, you can get that one. So A minus 8 into Z is B minus 15. So Z is B minus 15 by A minus 8. Similarly, Y plus 2Z equals to 3. From that, Y equals to X equals to 6 minus. So that X is also calculated. Okay, so if you choose the values of A and B is any value you choose it, A is except not equals to 8, you will get a solution. Okay. Case 3. If A equals to 8 and B equals to 15, A is 8, B is 15, then what happens? Rank of coefficient matrix is 2, rank of augmented matrix is also 2, but it is less than the number of unknowns, which is 3. Therefore, the system is consistent, but it will have infinite number of solutions. In terms of how many constants? N minus R constants. What is N? 3. Rank is 2. 1 constant. So that is written here, 1 constant. Then x plus 2y plus 3z equals to 6. From that, y plus 2z equals to 3. So I have to choose z equals to k. If I choose z equals to k, from this I will get y equals to 3 minus 2k. And if I substitute that z equals to k and y equals to 3 minus 2k, I will get my x is k. So this is, you can choose k any value, therefore you will get infinite number of solutions. Okay, I hope you understood this concept. Thank you.